Alright, this is a video about capacitors and how they could stop voltage drop. Not like a ripple cap, but something a little different. So we're going to start here tonight, and I am going to show you that this is a 2-cell cap, and we're going to check voltage on it now, show you that it's at 0. And there you go, 0.1 volts. So this is the first cap that we're going to charge up, and then this is the second cap. It's a extreme cap, 2-cell, and this cap is also 1 volt. So both of these caps are discharged. The amount of current that a capacitor charges to typically is what it will discharge instantaneously into its load. So with that being said, I have a 2-cell battery I had to whip together tonight because I don't have any 2-cell batteries left. And you can see on my little meter here, we're at 8.3 volts. 0 amps have been pulled through this meter, and this will scroll some different information about what's happening. And we'll start from here, which is volts nominal, ampere hours, amps peak, watts peak, watt hours. So when we connect the load to this device, it will show you current being pulled, the current voltage, and how many watts have been consumed. So in this case, the battery is our source and the capacitors are our load. And so for this little guy, we're going to plug him in first here. We're going to see how much he's going to pull on inrush current. Make sure you get to see that good. All right. So she's fully charged. It's at 0.14 volt amps, so that means that it cannot push any more current into the differential of the load. So we can disconnect this right now, and we'll be able to see that this capacitor was 165 watts peak, and it consumed 20.44 amps to fully charge it. So this little capacitor is capable of discharging 20 amps or 165 watts into a load. And we dropped our battery voltage just a wee little bit. So now I'm going to disconnect this battery, and we're going to charge this one up. If I don't disconnect this battery, then these numbers won't zero out. So now we're all zeroed out. And now you already know that this cap is at a 0 charge state. I'm going to do the same thing. We're going to see what the meter says this capacitor will charge to. And it takes a little while for this to get down to a state where it is no longer being charged. You can watch the current, the top left, drop. As that's dropping, it tells you that the voltage is charging up in the cap. And when we get down to practically nothing, half an amp, less than half an amp, we know this capacitor is completely fully charged. is still dropping, so it's still charging. This one has a greater capacity, as you can tell, 99.91 amps peak. $729 watts. So that's about enough right there. That current's right around 0.29, 0.30. So I'd say this guy is fully charged. Gonna disconnect him. We're gonna look at that number. 99.91 amps peak, 729 watts. It's almost a horsepower. So that means that this capacitor can discharge enough energy instantaneously to cover 1 horsepower of your voltage drop at 2 cell. And you can make this cover that same amount at any cell. The 8 cell caps do the same thing. The 8 cell caps, I'll have to get one together to show it charging up. They charge to 125 amps at 33.6 volts. So I just wanted to give you a little demonstration on the capabilities of a capacitor to eliminate voltage drop in your particular RC application. I hope you enjoyed the video, and I hope you have a great night. Bye-bye.